Hi guys, quick one today, and I have this sort of solar powered lamppost thing. I brought a couple of these for a project with the intent of taking them apart and making them work in ways they weren't intended to. This one worked outside in the way it was intended for about a day and packed up. I don't think this solar panel is really up to the job, so I'm going to crack it open, and I thought I'd grab you guys while I do it and see how we can make this do what I want to do. So the idea with these is I want a number of these to go around a horse arena to be charged from a single solar panel rather than the individual ones. Unfortunately, using these as a stand isn't going to happen because we've found a problem with them and they're not actually suitable as they're designed anyway. So there are several modes to this. I can't demonstrate them because the battery is completely flat. The motion sensor modes aren't that useful because they don't stay on for long enough, and if you're moving a horse around an arena you don't really need the lights going on and off. It also turns out we've discovered that when the battery in this goes completely flat, it forgets what mode it was in. So if you put this 7 foot up a wall and it does manage to go flat because there's been a couple of bad days of sunlight, you need to go and poke this or use the remote. This didn't actually come with a remote. So we've got the screws out. Let's pop this off, and this is about what I expected to see in here. So we've got one 18650. We have an off-the-shelf PIR, a little tactile button. There's our LED array there. How many have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 LED chips per cob. And they look like they're on a little aluminium substrate. I love the way that we've gone to the effort of making it look like it's heat sinked, but it really isn't. So there's our cobs. And how are we wired? I think each array, looking at this is this horrible white on white that they use. As far as I can tell, the positive comes down here. I think we are series and parallel on these. I'm not going to go Big Clive style and go right into them. If you are interested in LED lighting and things, then go and have a look at Big Clive's channel. I think I can probably cut a card up there for you. The build quality on this is a bit pants, to say the least. That wire's about to break off, and this board is going to have a blob on it, I suspect. The good news is there's a lot of room in here, which means we could make this do things it wasn't intended to quite easily. No, we don't have a blob, we actually have a chip, and we've got another really bad solder joint down here. Oh no, they've just put the end of the solar panel through and left it loose. We have a chip with no name. Wasn't that a Pet Shop Boys song? So that will be doing the various functions. We have a MOSFET that is being driven from that chip through there. Where's my pointer? And get a bit closer for you. Zoom in! I think that's in focus. So we have our micro. We have a line here that drives this MOSFET through the resistor. This resistor, this MOSFET is switching the negative to the panel. The solar panel negative goes up through to the chip. The negative is also used for the key switch signal. Solar panel positive goes straight through there. Negative supply. No, okay, take that back. So we've got the negative from the battery here, we've got the negative from the solar panel here. Positive to the solar panel is charging this via a single diode. The micro is not involved in this at all, which that's not great. That's also very light. So we're relying solely on the lithium ion to regulate its own charge. That's probably not a really safe way of doing things. I don't think there is anything special happening here. So we're literally placing the output of this straight across this. So although it looked like quite a nice unit, it's not that great. This can quite easily run this battery down way past the level it should do, so there's no charge protection going on. I don't think there's any charge protection going on here. Our positive supply does go there, however it may be that when the voltage drops off this does actually shut it down. I assume that is going to constantly draw current though. So yes, this is quite possible that this can undercharge or overcharge the lithium battery. That's not great. So my plan, my problem is this board. Where's that cover? So I just noticed, me saying that I didn't receive the infrared remote for these, there is no infrared remote receiver. Even though I had received it, it looks like it's just a... Oh, I don't know actually, there is genuinely no provision for that. So I'm guessing this is just going to be a micro that handles the different modes this does. So your modes are always on when it's dark, on when there's motion detect, or dim until motion is detected, then it comes on full power. So I need to change these into dumb light heads. So I'm going to need to cover that up and pass a cable off down to the support pole here. The other problem with this is going to be that we're running at 12 volts, so I'm going to need to make some kind of power arrangement for that. It would have been nice to have been able to rescue some of this, but I don't even trust that battery. There's no weight in that at all. There's no capacity. The only thing I can do is make sure, well, that is fully discharged now, and charge it up. Bear with me, let me just pause you. Right, that battery was at 2.5 volts. That's not really a good place for a lithium to be. Let's just power this up. This is a freshly charged. You can tell it's got a tick on it. Yeah, that quite obviously has not remembered the mode it was in. So you've got on. Let's start again. So that's on when it's dark. So if I turn that over, that'll go off. I can see spots now. And then we've got dim until motion is detected. I don't think I can hold it still enough. And then just dim, I believe. Yeah, and off. I suspect that is always drawing power, so yeah, it's the danger with these cheap Chinese lights. Again, Big Clive has covered it enough times. You quite often get little solar lights like this. They either use a lithium ion like this or nickel metal hydride, and they nuke the batteries. They either overcharge them, undercharge them, or do both. So your pretty solar lights last for about a year if you're lucky, or if they make it through summer, and then they're dead. So I need to potentially make something to temporarily replace that board to give me constant current for the LEDs off of 12 volt. I don't really want to whack one of the modular power supplies I've got in here. And we need to go and try it on the Arena. We won't use this solar panel at all. I don't know that there's a lot of point. I'll probably just disconnect it and leave it, because there is hopefully a 300 watt panel to run the battery bank that will run all of this equipment, so they wouldn't be needed. So yeah, we need to whack a power supply in there and see what happens next. Anyway, cheers, bye.